Hello everyone, we are going to solve chapter 12's lab, and it's about configuring IPv6 addresses on network devices. As you can see, we have this topology here. We have two PCs, we have one switch, and we have one router. We also have given the address table, and what are the objectives is first to set up topology and configure basic router and switch settings, and then we need to configure IPv6 addresses manually, and finally we need to verify end-to-end connectivity, as you know, using the ping or traceroute commands. So in the scenario in this lab, you will configure hosts and device interfaces with IPv6 addresses. You will also issue show commands to view IPv6 unicast addresses, like show IPv6 show IPv6 brief or show interface and so on. We will see, and you will also verify end-to-end connectivity using ping and traceroute commands. Okay, we have also here one note related to the real devices, but now we are using packet tracer, so we are using packet tracer, so we don't need to issue this device. However, it's a note that the default BIOS template used for switch database manager SDM does not provide IPv6 address capabilities. Verify the SDM by using the dual IPv6 and IPv4 and IPv6 template or the LAN-based routing template. The new template will be used after reboot. So we have to issue this one in the real device, and then configure terminal and issue this command to enable the dual default IPs, IPv4 and IPv6, and then we need to reload. However, we will not use this here in IPv because we are using packet tracer. What are required to be what are the requirements? We need one router, and the type of the router for 4221. We will use this one, and one switch. It's 2960, and we need two PCs. This is PC1 and this is PC2. And I think this is the topology pretty much the same, and we need the cables from Gigabit Ethernet 00 to Fast Ethernet 01. Also we need F06 Fast Ethernet 01, and we need also F05 to Gigabit Ethernet 001. Okay, so we have this topology now. This is PCA. This is PCB. Okay, and this is router 1, and this is switch 1. So let's see what we need to do in part 1. Cable the network and configure basic router and the switch settings. After cabling the network, initialize the router and reload the router and the switching template as following. Configure the router, assign host name, and configure basic device configuration. We will only assign a host name here. No. Enable configure terminal, and then host name R1. We will not give like passwords. We will not set the command line, the VTY or SSH1. It's fair because we did that in the previous chapters or labs, packet tracers. So we will focus only on IPv6 configurations. Okay, for host, also for the switch, we need enable configure terminal, and then hostname s1. Okay, so in part 2 we need to configure IPv6 addresses manually. Assign the IPv6 address to Ethernet interface on router 1. So assign the IPv6 global unicast address listed in the address table to both Ethernet interfaces on R1. So let's do this one. On R1 we have two interfaces and we assign the global unicast address to these interfaces, Gigabit Ethernet 000 and Gigabit Ethernet 001. So let's do this. Interface Gigabit Ethernet 000 and ID version 6 addresses 164 with subnet mask address, and of course we need to activate the interface. And again, same with Gigabit Ethernet 001 and IP address 1 according to the address table, and of course not down. Okay, so then we have to verify the correct IP address unicast address is assigned to each interface, and to do this, to verify the interface, we can exit, again exit to go up, and then show IP version 6 interface brief. So what we have here, we have the same IP, show IP interface brief from IP version 4, but here we only need to add IP version 6. And let's see what is here. We have both the interfaces up for Gigabit Ethernet 00. We have, this is the global unicast address, and this is the link local address, as you can see here. And also the same for Gigabit Ethernet 001. This is what we assigned. So we asked to verify only this IP addresses. Okay, so to get the link local address to match the global unicast address on the interface, manually enter the link local address on each of the interfaces on R1. So now we need to set the link local address in this interfaces, and according to the table we have the link local address here for PCA. Link local address is FE001 and FE81, FE81 on the interfaces. So let's do this. Configure terminal. Interface Gigabit Ethernet 000 and IP version 6. Address FE81 link local. The same here for 1. And the same thing here also. What we have to do else, use the command of your choice to verify that the link local address has been changed to ZFE001. We will use the same command here. show IB interface, show IB version 6 interface brief, as you can see here and here. Or you can also use the show IP version 6 interface gigabit 0, 0 and 0, and you can see here all the information about this one. We have the IP version 6 link local address is this one. Okay, and that's it. Use the command of your choice. Okay, which two multicast groups have been assigned on the interface gigabit Ethernet 000. So we need to check the multicast group on this interface gigabit Ethernet 000, and this here, but we can see this from this command only, because from gigabit Ethernet show IB interface version 6 brief does not show us the multicast information, but from this command show IB version 6 interface gigabit Ethernet, or the interface name, we can see the multicast group. And as you can see here, the multicast group, we have FF021, this is a multicast group, and this is here for the from the router. It's solicited nodes multicast group. So this is the multicast group from FF021 and FF01. Okay, so then we need to enable IB version 6 on the router, and on BCB command prompt enter IB config command to examine IB version 6 address information. So let's go to BCB, let's see IB config, and as you can see here, have an IB version 6 Unicast address being assigned to the network interface and network interface card. We can see here, no, it is not assigned, because we did not enable the IB version 6 on the router. So enable IB version 6 routing on R1 using IB version 6 Unicast routing. Let's do this. Configure terminal, IB version 6 Unicast routing. Okay. Use the command to verify the new multicast group are assigned to the interface gigabit Ethernet 00. Note that the all router multicast group FF02 now appears on the interface gigabit Ethernet 00. Let's see. Again, interface gigabit Ethernet 00. Let's see what we will have here. As you can see here, this one is here. And global unicast address is assigned to this global unicast address, and here we have joined to the group, and hosts use stateless auto configuration for addressing. So SLAAC is now used in this network. Okay, so we can notice now here that enable IP version 6 routing on R1 using IP version 6 routing. We already did that, and now we use the command to verify the new multicast group as assigned to the interface gigabit Ethernet 000. Notice that the all router multicast group FF022 now appears for interface gigabit Ethernet 000. Let's see that. Okay, enable. Then we have config show IP version 6 interface gigabit Ethernet 000. As we can see here, this is the now multicast address, and by this the router is now part from all the multicast group. and when it's part from the multicast group, it allows it to send the router advertisement message RA. If you remember, when in this message it says that to the neighbors, hello, I am the router, I am using the global address with this subnet mask and with this subnet, and I'm also this is my link local address. If you remember, we mentioned that in the lab, the RA message that's generated by the router, and from this message the PCs will generate their own IPv6 address. So let's see this. If we will go here, first we have to make sure that is automatic, and then let's close this. I'm going to go here and type ipconfig, and you can see here now the PC obtained its IPv6 address using the SLAAC method. Okay, why did BCP receive the global routing prefix and subnet ID that you configure on R1? Because of the router advertisement message. Now let's move forward to step 3, and here we have to assign IPv6 addresses to the management interface SVI on the switch. So now we finished from the router, we need now to configure the switch. What we have to do, again, enable and then configure terminal. We need to give an IP address to this switch virtual interface SVI according to the table. So interface VLAN1, and inside the interface we need to type IPv6 addresses. What was the IP for the VLAN1? It was this one. Prefix 64. Okay, so let's make sure. So this switch does not support IPv6. So we will use another switch which supports IPv6. Let's see, and it's this one. Let's delete this one from here, we don't need it anymore. This one too. Gigabit Ethernet 01. What about the switch? It's need a power supply on it. So to do this, we can drag this one here, and then let's try to see if we can access the command. Now it's initiated. Okay, and now let's try to do again. Process one more time. Enable configure terminal host name S1. This is now S1, and we need to assign the IPv6 to the interface switch virtual interface. So to do this, we need to interface VLAN1, and then we need IPv6 address. Yes, support. Let me take this. 64, and also we need IPv6 address FE80 as link local address. Always when we assign IPv6 we should put link local address as well. Okay, we can exit. Now we need to verify that the IPv6 address are properly assigned to the management interface. We can do this by show running configuration, or we can also do this using show IPv6 interface VLAN1. And as you can see here, this is the IPv6. Okay, and this is the link default gateway or the link local address. Okay, so assign static IPv6 address to the PC. So open the Ethernet properties window on the PC on each PC and assign IPv6 address. Okay, so we need to give a static IP address is given here. So let's close this for PCA. And for PCB, so we can ping from PCA BCP, and from let's ping the gigabit Ethernet from PCA 000, and then let's try again to ping this one. Okay, let's try configure terminal and then interface VLAN 1. No chip down. And exit. Okay, now it seems okay. Let's see if we can ping it. Yes. So the problem that I did not activate the VLAN interface. That's why I could not ping it. However, it doesn't affect the overall performance because, as you know, the VLAN 1 interface and the switch is only for remote access. We don't need it now, but just in case. Okay, so we ping S1, so we have to use trace RT command from R1 to R to PC, from PC1 to PCP. Let's take the IP address of PCP. Then we use trace RT. We can see here we have um, two interfaces. One is here, second one is here. This is two hops. Trace complete. It's different than the ping. We have also now the time on each node. And what else? We did this also, and that's all. If the end-to-end connectivity is not established, it established. So we did the troubleshooting as well. We only checked the VLAN was SVI was administratively down, and that's it. Okay, that's all for this video.